I'd now like to introduce the next panel, which will really, as we previously mentioned, go into more detail on understanding the energy consumption by AI systems. The next panel will focus on what factors are contributing to the exponential increase that we're currently seeing in the energy consumption by AI systems and how the trend compares to the global energy use. They're discussing strategies and innovation that are being deployed to reduce the energy consumption. And they are discussing how the tech industry can balance the benefits of AI with the need to conserve energy and protect the environment globally. So to do so, I'd like to introduce the moderator, Monsieur Bertrand Le Tallec, economic advisor at the French Embassy in Berlin. He'll be joined on stage by Professor Dr. Eric Masanet, who's the head Industrial Sustainability Analysis Lab of the University of California, Santa Barbara. Professor Dr. Lynn Knack from the Hertie School, Computer Science and Public Policy, and Hugues Ferreboeuf from the SHIFT project. He's the advisory board member of the European Green Digital Coalition. Thank you very much.
Please. Please, have a seat, please. Welcome here to this very important panel today. AI and electric consumption is a very important topic today. And I will make a very short keynote for the beginning because we founded, maybe it's coming, yeah. During a summit in Paris in February, a group of countries and many organizations and companies created a coalition for a very sustainable AI in the world. It's a very important decision that was taken in Paris, and we have 3 pillars on this very good approach. Encourage AI initiative for the environment, AI respectful of our planetary boundaries, and support collaborative efforts. So we have only 30 minutes today. We won't be able to reach all the topics of this coalition, but we will do our best to give you a very good picture of what can be done and what has been already done in this topic. So we are very pushing to be very pragmatic in the future. So we have a very good engagement. We can identify and connect stakeholders that are very active in AI and consumption, electricity. We can put together people with initiative hubs all around the world today, and we promote open and international and collaborative initiatives all in many countries abroad. And one point is also very important, communication. We need to be very proud of that and to be very active and pragmatic. So you can see all the members around this initiative. There are many, in many continents, many companies, many organizations, many governments, United Nations, and ITU. So we are here. It's a very broad initiative, and we can be proud of it. So, dear ladies and gentlemen, now we have a great pleasure to... Oh, welcome. Welcome. We have a beautiful and amazing panel today with people coming from America, from Germany, from France, and maybe from Great Britain. Our colleague has been delayed. Let me introduce Eric Masanet. Eric is a global expert on analyzing the energy use of data centers, having researched in many years, decades, in public organization, US government and research centers, and in many companies too. Professor Dr. Lynn Knack is assistant professor of computer science and public policy at Hertie School in Berlin, and she is also a co-founder of the Climate Change AI organization. And Hugues Ferreboeuf, a French European Green Digital Coalition member, and you are in the board of the think tank, the SHIFT project, a very important think tank about energy consumption in France. Maybe, Hugues, can I tell you the first question? What factors are contributing today to the exponential increase of energy consumption by AI systems in the world? Please.
How much time do I have to answer?
5 minutes.
5 minutes, wow.
Yeah.
Wow.
Whoa.
I was expecting 30 seconds. Okay, I'll start, but I guess my two colleagues will complement what I'm going to say. I think the factors which act and are such that the current deployment of AI appears to be unsustainable are the same as the one that have been in place in the past 20 years in the digital ecosystem. The only difference is that it's faster, bigger, and probably a bit more difficult to analyze with AI. So what do I mean? What I mean is that, and that's a figure we published 7 years ago, and I think it's, at least the order of magnitude is agreed upon by most people. Digital represents about 3 to 4% of GHG emissions in the world, and digital consumes about 10% of the world electricity. That's one thing, but the most important thing is that these two figures, they probably increase in the range of 5 to 6% a year. And why do they increase? Not because of a lack of energy efficiency, but because this progress in terms of energy efficiency are utilized in order to create additional consumption. And that's the famous rebound effect that was mentioned in the last roundtable. But why is there such a rebound effect? There I will not need 5 minutes, but probably more 1 hour. But what we have to understand is that this rebound effect is related to factors which, for most of them, are not non-technical. It's related to the way the market is organized. It's related to the business models which are in place. It's related to societal norms which are accepted. And it's related to regulation, which, for instance, encourages competition through infrastructure. And there are also factors and so on. And last but not least, let's say, financial interactions and the fact that these business models, which are the ones of the big tech, and which prove very profitable, are so much profitable that the good parts of the financial community now depends on the result of this big tech, and nobody wants them to fail. So that's for the overall digital ecosystem. And what about AI? First, when we say AI, it's a bit misleading because what has really been going on in the past 2 years is about generative AI. There was AI before generative AI. There will be other forms of AI after generative AI. But the fact is that the form of AI, which is very much pushed forward by these same companies, the big tech, is generative AI. And I will let my academic colleagues to explain why generative AI is so much power hungry. But basically, it has a limit, but basically the performance of a Gen AI application is going to depend on the magnitude of the data it's going to be able to rely on, and on the, let's say, the speed at which it can process this data. So that means they are going to need more and more power as they want to increase performance. Okay? And what is going on with AI, that's for the technical part, but on all the other aspects, market organization, financial, and so on, AI is just making things bigger and faster. There's never been so much money invested in computing infrastructure. 1 year ago, when we were talking about a large data center project, it was about, let's say, $500 million, $1 billion. Now it's $10 billion. So tomorrow, what would it be? 50? Okay. So it's, and all of this money, of course, somehow in the future, and I will stop there, somehow in the future, all these investments will have to get return. So in order to get return, all these companies which are investing a lot will make sure that we're going to use Gen AI, even though it is not the most adapted technical solution for a lot of things. And I will let my colleagues continue maybe on this note.
Yeah, there is a huge consumption development in AI today. How can we compare it with the global energy consumption? It's there is a very big difference of AI consumption increase in compared to the global economy today.
Yeah, I said that digital is consuming about 10% of electricity consumption. At the moment, I think it's more in the range of 11% than 10%. If you focus on data centers, because that's the most visible part of the topic, in the world, data centers are consuming about 2% of the overall electricity consumption. In the US, I think it's in the range of 4 to 4.5%. So it's already significant. But what is more significant is the fact that this consumption is going to, depends on the studies, but is going to double or triple in the next 7 to 8 years. Okay? And what does it mean? And that was very clear in a forum that was organized by the International Energy Agency in December. It is going too fast for the power industry. Power industry is not adapted to this type of pace. So what is happening? In order to be able to power these new data centers, the digital players now have to set up their own power plants. And what is the most practical way of setting a power plant today? It's just going to be a power plant powered by gas. Okay? So that's in a very summarized way what is happening, certainly in the US. I think Eric might confirm that. Mm-hmm. And there is a risk that it happens in other regions. And I would very much like that we have a better vision of what could happen in Europe, because at the moment, it's far from being clear.
Thanks a lot, Hugues, for your testimony. And Eric, can you tell us about the projection of electricity consumption by AI systems in the world? They vary a lot. What is your opinion? What is below that?
Thank you for the wonderful question. And I think I would just first like to reinforce everything that was just said about the trajectory of artificial intelligence and data centers in particular. And perhaps I could answer that question from a US context. So my colleagues and I at Lawrence Berkeley National Lab have been studying the issue for nearly 2 decades. We build models, we make projections, we try to inform the government about the direction of the industry. And in our last report, which came out in December, we found that the growth of data centers was quite substantial in the US, largely driven by the deployment of AI computing. So it is around 4% of US electricity use. Our forward-looking scenarios suggest it may go up to 6%, even as high as 12% in the next 3 or 4 years. So it's certainly an energy demand growth problem. And I would like to say also, there are 3 major epicenters of AI deployment happening in the world, right? The US, I believe, has been on the front lines, and as analysts in the US, we've been trying to study the issue, and understand where it's going given the available data, but there's also Europe, and of course, big black box is China, right, in terms of AI deployment. But we have learned some lessons about how to analyze this sector. And I would like to sum it up perhaps with two major findings. The first is the analyst community is really important for informing policymakers, informing researchers, informing the public about the scale and directions of this sector, and we don't have sufficient data to really do so in an accurate way. One of the main reasons is AI, right? Nearly every week we're seeing an announcement of a new mega campus. We used to measure the size of data center campuses in megawatts, hundreds of megawatts, maybe even tens of megawatts. Now we're talking gigawatts, right? Billions of dollars of investments. Those announcements are happening all the time, but it's not really clear if they'll come to fruition. Will they be used at full capacity? If we sum up all the announcements, is there enough power to even supply the power needed for all those announcements? What will be the need for backup generation and so forth? So there are many unknowns when it comes to analyzing this sector. We also suffer from a lack of, frankly, transparency from the tech industry itself. So most major tech companies will report their energy use, but rarely at the level of the data center, and rarely do they give you any insight into what's happening in any individual data center, such as an AI data center. So we're often making a lot of inferences and assumptions about the power profiles of AI data centers, their levels of efficiency, and where it may be headed. Hardware manufacturers could also help address some of these data gaps by providing better information on power profiles. We don't have a good understanding of the materials going into these machines as well to understand life cycle effects and so forth. So in the study that we just completed in the US, which also supported some of the work going on at the IEA, we tried to ring the alarm bells that we need to double down on our ability, meaning government data collection, new data partnerships, a new era of transparency to provide the data to give the analyst community a much better picture of what's going on. I will say, though, that there are generally two types of studies that you'll find out there in the public domain. And if you're like me, you're probably a bit frustrated. You look at one study and it predicts a 4x growth in data center demand, another will be 2x, another will be 10x. Most of the extreme predictions are coming from what I would characterize as simplistic analyses, meaning simply extrapolating the past into the future. For this sector, that's never really a good approach because the technology, the applications, the efficiencies can change so quickly. However, I will say that no matter the method, the directionality of energy growth is pretty substantial. It's going up, there's no doubt about it, right? The gold standard is something called a bottom-up model, where we understand the numbers of servers, the numbers of data centers, their configurations, their energy use profiles, and so forth. One can imagine that those sorts of models require lots and lots of data, which aren't necessarily available publicly. These are the methods that we use in the US, and the IEA recently used these methods as well. In order to populate those models, we need much better data to, I think, sharpen or reduce the uncertainties in the estimates that are out there. But essentially, that big difference we're all seeing in estimates comes back to the assumptions, the methods, and the lack of data. Everyone's doing their best to put the best numbers on the problem space, but we need better data in order to have a sharper view. And I think better data will also help policymakers understand and even simulate different paths forward and the ability of policy to bend the curve. We lack that ability in a robust way today as well.
Okay, thanks a lot. So, to your opinion, what factors might alter high energy demand trajectory, and who controls them? Market development, new technologies, maybe more efficient?
I think all of the above. If we think of just a data center itself, an AI data center, it's not clear that they're being used at full capacity. And frankly, what's happening now is either a gold rush or an arms race, however we want to look at it. Everyone's investing in AI because they don't want to be left behind, but it's not clear just how well utilized that equipment will be. So utilize